Hi students, hope you all are good. So let's start with the new topic of numerical methods. It's numerical solution of algebraic and transcendental equations. Now to start with the solution of these equations, first we need to understand what these equations are. Okay, so look at this expression. F of x is equal to a naught times x raised to power n plus a1 times x raised to power n minus 1 plus so on up to an minus 1 times x plus an, where all these a's are constants. A naught must not be equal to 0. This n, this degree, is a positive integer. So this expression is called a polynomial in x of degree n. When you put this polynomial equals to 0 like this expression is f of x equal to this value, right? Now this whole value is put equal to 0. Now this is called an algebraic equation of degree n, this degree n, right? Now when this function, this f of x, when it contains some other functions such as trigonometric, logarithmic, exponential, etc., then this equation f of x equal to 0 is called a transcendental equation. So this is the major difference in the algebraic equation and transcendental equation. The transcendental equation contains these kind of functions in it. Right. Let's have a look on the examples of such equations. The first one is obviously algebraic equation. The second one is containing tangent x, so it's an transcendental equation. Third one is containing log x, so this one is again transcendental equation. The last one is algebraic equation with degree 3. Right. So again, to start with the solution of these equations, let's first understand some basic properties of these equations. Okay. Look at the first property, the basic properties of these equations. The first one is, if f of x is exactly divisible by x minus alpha, then alpha is a root of f of x equals to 0. Obviously, if this is the equation and the left hand side f of x, if it is exactly divisible by this x minus alpha, then x equals to alpha. This alpha is a root of this equation, right? Second, every equation of nth degree, like for example this equation is of nth degree, so how many roots it will have? It has only n roots. So how many number of roots an equation will have? It will be equal to the degree of that equation. Okay, so the roots can be real or imaginary, or the sum of the number of real and imaginary roots, right? Third property is intermediate value property. Important one, it will be like used in the iterative methods that we will use to find out the solution of these kind of equations, so you need to understand it. If we take one closed interval a comma b and our equation f of x equal to 0, this is our equation. So this f of x, if it is continuous in this closed interval a comma b, continuous means for every x in this interval there exists the value of f of x. Or if you talk graphically, so when you trace the graph of this function in this interval, so this will be an unbroken curve. So that's why we call this is continuous. Okay. So this is the first condition. You will check this, that in the closed interval a comma b, if your function is continuous. Second, at this point a and b, if you put these two values of x in this f of x, like this, f of a and f of b, right? If these two values have different signs, different sign means that if one is positive, so other is negative. Okay, then the equation f of x equal to 0 has at least one root between this a and b. Okay, in this closed interval a comma b, there will exist at least one root of this equation. When it will exist? When these two conditions will satisfy, that this f of x is continuous in this closed interval and when I put these two extreme values in this function f of x, I'm getting different signs. Okay, then there will be one root that we can find out using our iterative methods. Got it? This is the intermediate value property. Fourth property, in an equation with real coefficients. Now, which real coefficients he is talking about here? Now, let's look at this expression again. These a naught, a1 up to an minus 1 an, these coefficients. He is talking about these coefficients. If all these are real, okay, then the imaginary roots occur in conjugate pairs. Then in that equation, if there exist imaginary roots, the roots will always be in conjugate pairs. Conjugate pair means if one root is alpha plus iota beta, the other will be alpha minus iota beta. This must be the root of the equation if this is the root of the equation. Okay, so all the imaginary roots will exist in conjugate pairs in this equation if all the coefficients of this equation are real. Got it? This means if we are solving an equation in which all our coefficients are real, and if there exists imaginary root, let's say you have already calculated a root that is a plus iota b. So you will say that yes, a minus iota b will also be the root of the same equation. It is must. Okay. Next property. Before starting with the next property, a corollary of the same, the fourth one about the imaginary roots, that if we talk about an equation of odd degree, like the degree of the equation is 3 or 5 or 7, something like this, then it has at least one real root. Obviously, if any equation of odd degree has imaginary root, so imaginary root will be in conjugate pair. So it can be 2. Like if the degree is 3, so there is a possibility of the imaginary roots be occurring, that will be 2. So if there are two imaginary roots, the single one that is left cannot be imaginary, as the imaginary root is always in form of pairs, right? So this one will always be a real root. So that's why it has said that there is at least one real root in case of odd degree. If I talk about the degree is 5, so 5 means there can be two pairs of imaginary roots, 1, 2, and third last one, 1. This will be a real root. This is the possibility that this is the pair of imaginary root, this is the pair of imaginary root. It is not necessary. All the 5 roots can be real roots, right? But if there are existing imaginary roots, so they are existing in pairs. There can be only one pair. These 3 can be real roots. So these are the possibilities, okay? Next property is Descartes' rule of signs. Now this again, this rule is again about to check the nature of roots of the given equation. Okay, so how it works? If we talk about an equation f of x equal to 0, so what this rule says that this equation can't have more positive roots than the changes of signs in f of x. You will observe your f of x, you will check how many changes in signs are. Change in sign means when you jump from one term to other term, is the sign is changing from plus to minus? For example, look at this. This is the equation. So if you jump from this term to this term, now this term is a positive term, so plus to this minus. Positive term to a negative term, one jump. Negative term to a positive term, other jump. Again positive to negative, other change in sign. Right? So he is talking about these changes in the signs. So the equation f of x equal to 0 can't have more positive roots than the changes of signs in f of x. Second, if you find out at the place of f of x, if you write f of negative x. Now in this equation, you will find out the changes in signs. Then you will say that the same equation f of x equal to 0 can't have more negative roots than the changes of signs in f of minus x. Now let's understand it using this example. I'm taking this example. Here the value of f of x is this one, that is 2 times x raised to power 7 minus x raised to power 5 plus 4 times x raised to power 3 minus 5 equals to 0. Now this is my f of x. Now I'm writing here the signs. Like the first is a positive term, so I'm writing it positive. Here this term is a negative term, so here I'm putting a negative sign. This term is a positive term, so I'm putting a positive sign. This term is a negative term, so I'm putting a negative sign. Now I am going from one term to other term. Plus to minus. There is a change in the sign, so I put one change in sign. Minus to plus. Again there is a change in sign, so I will write down my second change in sign. Then plus to minus, again there is a change in sign, so I will write down my third change in sign. So how many changes in sign are? 3. This means according to this Descartes rule of signs, this equation cannot have more than 3 positive roots. It says more than 3 positive roots. This means the number of positive roots can be either 3 or less than 3. It cannot have more than that. Okay. Similarly, if we talk about the negative roots, so again, now what you will do, you will put at the place of x, you will put minus x in the same equation like this. Okay. Now as the powers are odd, so negative x raised to power 7 will give you a negative x raised to power 7. Okay, so that negative will come here. Again, minus x raised to power 5. It will give you a negative x raised to power 5. So that negative and this negative, it will make a positive. Right. Then negative x raised to power 3. It will be negative x times negative x times negative x. That will give you minus x cube. Okay, so that minus x cube times this plus 4. That will give you a minus 4x cube. And this minus 5. Now again we are going to write down the signs of these terms. The first one is a negative term, so you are putting a negative sign. Second one is a positive term, so you are putting a positive sign. Third one is a negative term, you put a negative sign. Fourth one is a negative term, you put a negative sign. So when you move from this to this, there is a change in sign, so you put put 1, number 1, right? Plus to minus, again there is a change in sign, you put number 2. Then this minus to minus, there is no change in sign, so you are not writing any change in sign here. Okay, so how many change in signs are here? 1 and 2. So this means this f of x equal to 0. I'm not talking about f of minus x. You are talking about the same equation that you have taken here. This one. So this equation cannot have more than 2 negative roots according to this. Okay, so this means now this equation, it can have at most 3 positive root. It can have at most 2 negative roots. But the degree of this equation is 7. Right? Then what about the other roots? It must have 7 roots. So if there are at most 3 positive roots, if there are at most 2 negative roots, so these are total 5 roots. Okay, now these are 3 positive real roots, 2 negative real roots, so 5 real roots are there. Then what about the other 2? This means the other 2 roots are imaginary roots which are occurring in a conjugate pair. Got it? So how can we understand the nature of roots using this Descartes rule of signs? The number of positive and negative roots are the real roots. You will count them. Then how will you find out the imaginary roots? This is the way. That if in an equation of nth degree, if it has at the most p positive roots and at the most q negative roots, so how many imaginary roots it will have? The degree minus the sum of the positive and negative roots, like I have done here. Okay, so this way you can find out the number of real roots and the number of imaginary roots in the given equation. Got it? So this is all about the properties of these algebraic and transcendental equations. In our next lecture, we will learn how to find out the solution of such equations. The first method is bisection method that will use intermediate value property that we will discuss in the next lecture. Thank you.